Okay, everyone, let's start for today session. Today, I want to show you how to design any converter. Then, after how do you implement the MPPT on that converter? I will do some simulation also on that and show you how it will work. There the basic three converter. Just revise the basic converter. It's simple. Start from buck converter. Buck converter, boost converter, and buck boost converter. Three basic converter, DC-DC converter, which one applied in solar PV system to step up or step down the voltage. Yes, switch Q. And do you know about the output voltage? Is it DVS, duty time of input, and I naught is equal to V naught by R naught. Simply I want to write R only. And input resistance, so RS, taking the R now, RS is equal to VS by IS. For a power balancing, V naught I naught is equal to Vs Is. You can written V naught square by R naught. This will be Vs square by Rs. V naught is equal to D square by Vs square. V square will cancel out Vs square. As R naught is equal to D square into Rs. For the impedance matching for a maximum power transfer, this will be required. And second one is boost converter. Same thing you can do. V naught is equal to Ps. V output, I output is equal to Vs Is. This will be V square by R naught. V naught square will be Vs square divided by Rs. V naught in boost converter is Vs square divided by 1 minus D square. Vs square will cancel out, then here Rs or not is equal to Rs divided by f 1 minus d square. It means you can adjust duty cycle for a maximum power point tracking. Next one is a buck boost converter. Start there is a buck, then an inductor for making a boost. Here taken a negative of horn, that's why V output. The output voltage will be in positive in expression. Same thing you can apply V naught is equal to I naught, V naught is equal to VSIS. So V naught square divided by R naught. D square Vs square dVs divided by 1 minus D. Or naught is equal to D divided by F 1 minus D square into F Rs. By using these three equations, you can control the MPPT. Okay. For example, I have taken a buck converter. Sorry, just taken a question. A buck converter is operated with specification is input voltage is 72 volt, output voltage is 30 volt. The average value of current through the diode is 9 ampere. Then the input resistance of the converter. Vs will given is 72 volt. V output is given 30 volt and diode current is given 9 ampere. Just take a buck converter simple. Vs, V naught, take a R, C, L. This will be diode. This is ID, IS. This is a Q, inductor current. For a design of buck converter, first of all you have to know about the power rating and current rating, voltage, input voltage, output voltage. Then after you should have a knowledge of the ripple current and ripple voltage. Ripple current, it means the ripple current of inductor current which is present in this, and ripple voltage it means capacitor voltage, output voltage. And how much percentage of output voltage is the ripple voltage. Same thing, ripple current it means the how much a percentage of output voltage is the ripple current flowing through a inductor. If you know these two, then you can find the value of inductor and capacitor. Okay, you have three specifications given, and I'll taken as a delta IL as 20% of I naught, and data VC 0.1% of output voltage. These two specification is given, you can calculate the inductor and capacitor value. The first of all, inductor voltage VL when switch is on, when switch is on, then diode will be reverse bias because of the positive connected is here, negative connected is here, and current is flowing like that. VL is equal to Vs minus of V naught, and you know about the input inductor voltage, which will be L di by f dt. This will be Vs minus of V naught. If you want to calculate the inductor current, then what happened? Di by dt is equal to Vs minus of V naught divided by of L. If you want to execute expression of I, then simply integrate this one. Use the integrator, or you can use this one to transfer the DIT right side. Then apply integrator on both sides. Here the output voltage, input voltage is constant. Output voltage considered as a constant voltage. Inductor is also constant. Then this is the Di of 1 is equal to I is equal to same thing, all of thing is constant, and Vs minus of V naught divided by Fl. Expression of this one will be a time only one t and t plus something because of the integration required sometimes to have a initial value. Then what is the initial value? It will be I minimum. Then it will be increased because of the Q1, which is switch is if you want the switch, then current will be increasing. It means that it start from I minimum current to the maximum current. Same thing for switch is off. Then what happened? Then stored energy is transferred to the load by inductor, and current is flowing like that. That time VL is equal to minus of V naught. Same thing you can apply dl di by dt is equal to minus of V naught. Then di minus of V naught by L into dt. Same thing, integrate the both side. Then I output voltage also constant, inductor current constant. Then only T is there, plus it will be negative because of the switch is off, then slope will be negative, so it will be decreasing. Then from where it will decrease? What is the initial value of decreasing current? Will be I maximum current. The maximum current will be decreases. Sorry. Then just draw a waveform for this. Sorry. Same thing if you want to draw for a current of an capacitor. This will be I naught. And when switch is on, then IC inductor current will be a IL minus of I naught. When switch is off, same current will flow. IC is equal to IL minus of I naught. Because of the about the at the board's at the board's duration, the inductor current is flowing through the capacitor and load resistance. On time, off time, then again on. Suppose this is the duty cycle. What is the inductor voltage at that time? Inductor voltage Vs minus of V naught. Vs will be constant, V naught will be constant. Sum of the voltage is there. Yeah, this voltage is Vs minus of V naught. Then again when switch is off, then only a negative voltage is there, minus of V naught. Then again the switch is on, then it will flow like that. Vs minus of V naught. Any inductor I have positive voltage there, then inductor current will be increasing. Increasing from where? From I minimum. From I minimum, suppose this will be I minimum current. Somewhere is I maximum current. Start from I minimum to I maximum. This is the dt time. This will be a t. And switch is off, then negative voltage appears. Inductor current will be decreasing to I maximum to I minimum. It will be like that. Then what is the diode current? ID. ID current. ID current flowing when switch is on, then it will flow. Current is flowing like that. This will be reverse bias. Then diode current will be 0. Diode current will be 0 when switch is on. Again when switch is off, then inductor current is same inductor current is flowing through the diode. Then this inductor current is flowing through a diode, and diode current is flowing like that. And again 0. Same inductor current from here to here appears on the diode. Capacitor current and capacitor voltage. Sorry. Capacitor current is this will be IL, this will be I naught, then capacitor current is IL minus of I naught. Then I naught is the average current of IL in the buck converter. Then I naught is flowing like that. Average of this one I naught. Then if subtract I naught from inductor current, then capacitor current it looks like starting. This will be a 0 point for an capacitor current. This will be goes to down. Same inductor current is flowing through it. And starting from negative to positive because of this one. I naught is negative. That current is flowing like that. Capacitor current. Then capacitor voltage. We know about IC. VC is equal to, or you can say I is equal to dVc by dt. Then Vc is equal to integration of I into dt. If you integrate the ramp signal, then it will occur as the parabolic signal on output. And this will be the negative, positive slope. A positive slope is there, then parabolic is increasing. Like that. Average of this one will be, sorry, output voltage. Okay. Simple. This is the structure of the buck converter. And asking about the diode current is given in 9 ampere. Then diode current is this one. Then diode current is flowing after the switch is on. When switch is off, it means 1 minus D time. Then you can say ID is equal to 1 minus D time of IL. Then average of IL is same thing, I naught. You can find the duty cycle. by using a voltage equation. The voltage equation is output voltage D Vs, output voltage given 30, input voltage 72, and D will be 0. I think 42. Okay, you can find I naught, ID current divided by F 1 minus D. ID is given 9 ampere divided by 0.58, 15.54. If I naught is known, then you can find the output power, B output, I output. Then after you can calculate the input current. Now you can directly calculate the RS because of P output divided by F Vs. Oh, sorry, Vs is square divided by F P naught. P naught is same as the PS in ideal condition. That's why you can calculate from this. This will be a 15.5 into a 30 volt 465. Then this will be Vs is given 72 square divided by 465 will be 11.14. Okay. We'll find the value of input voltage 72 volt, out voltage there 30 volt, or 11.5, 11.15. I or not is 15.5 on. Then what is the or not? R V naught divided by 15. 1.994 ohm. Then in buck converter, you find the R, Vs, V naught is there, diode and switches you can choose accordingly. Then you have to calculate the inductor value and capacitor value. Inductor will be calculated by the delta IL. Delta IL will taken at 20% of I naught. I naught is 15.5. It will be a 3.1 ampere. Delta Vc 0.1% of output voltage. Okay, output voltage is 0.03. What is delta IL? How we calculate delta IL? Delta IL we have calculated by the voltage, inductor voltage is equal to Vs minus of V naught. VL is equal to L Ti by dt. Di by dt is equal to Vs minus of V naught divided by FL. Inductor current, then Di is equal to Vs minus of V naught. Same thing you can apply into dt. But here we have to apply a limit is there, because of you know about the inductor current flowing from I minimum to I maximum. From this period when switch is on, inductor current flow from I minimum to I maximum, and the voltage is Vs minus of V naught. And apply this one. So what is the time of this one? 0 to dt time. Duty cycle on time is dt. Same thing, off time 1 minus dt. Then it will be I max minus of I min is equal to Bs minus of V naught divided by of L into dt. I maximum to I max minimum, it will be delta IL. It will be Vs minus of V naught divided by of L into d into t. T you can retain as 1 by f, then you can f is downside of this one. Fine. It means you can calculate delta IL. L here, from here, L is equal to Vs minus of V naught divided by of f into delta IL, so into d. All of thing you have, Vs is 72 volt, V naught is 30 volt, duty cycle 0.42. So frequency is not there. Suppose take a frequency as 50 kilohertz for this operation. 50 kilohertz, it means 50 into 10 to the power of 3. Delta IL 3.1 calculated. Then find the inductor value here. 8 micro Henry. Okay. Then next one is a capacitor. How you decide the capacitor value? By using a Bell delta Vc. In the capacitor, you know about Q. Simply Q is equal to C into V. Okay, use change it in charges, same thing, it will be delta V, and you have to calculate this one, delta Vc for a capacitor voltage. Then delta Vc is equal to of delta Q by C. Delta Q, it means the change in charge of a capacitor. Charge capacitor will be charged when current is positive. If current is positive, then capacitor will charge. When current is negative, then capacitor will discharge. The changes are between them are, you can take as a positive or you can take as negative of the current of capacitor current. This is the capacitor current starting from here to here. This will total time period T. From here to here it will be positive. Then there is the negative current. Negative current is defined discharging. Positive current will be charging. So you have to take any one, a positive or negative. If you want to take a positive, then you have to calculate the total area of this one, because of you know about dq by dt is equal to current. If you want to take a current, a total charge, then you have to integrate of I into dt. It means if any integration of there, then it means the area of this curve. Then you can simply calculate the area of this one. This time is the same, which on the off time. Then you can take the total time. This one is t half. Half time it will be charged, half time of the discharge. Peak current, it will be a ripple current is there only. I minimum to I maximum is there only. Then the total height of this curve is delta IL divided by F2. Total current from here to here is will be delta IL. Half of this one will be charge, half of this one will be discharge. Then this will be the delta IL by 2. Then you can apply area of the triangle, half base into height. Half base into height, half base is time t by 2 and the height is delta IL by 2 divided by FC. Then this will be t 1 by half 1 by f delta IL by of 8 FC. Delta IL we have already calculated, Vs minus of V naught into D 8, this will be at F square L into C. If you want to calculate the value of inductor C, then this will be Vs minus of V naught D divided by of 8 F square into L into delta Vc. We have all of values these. We keep here 72 minus of 30 volt, 0.42 is the duty cycle, 8 into this will be 50 kilohertz, 50 square into 10 to power 3 square will be 10 to power 6. L I already calculated 113.8 into 10 to power of minus 6 micro, delta Vc 0.03. Okay. Calculate the value of C. 10 to power minus 6, 10 to power plus 6 will be cancel out. 72 minus of 30 into 0.42 divided by 8 divided by 50 square divided by of 113.8 divided by 0.03 2.58 microfarad. Okay, capacitor and inductor value is there, then you can calculate it value apply to your system. If same thing, okay. Have you seen the screen of MATLAB? In this, the voltage DC voltage source, we require this one, then we require the ILC series circuit, sorry, not a load, we require RLC series branch. Okay, now we have to select the inductor. Inductor value is calculate 113.8 into e to power minus 6. Okay, then requirement of capacitor. Capacitor value is 2.5. Take at 10 times of this one. This is 25.8 microfarad. Power minus 6. I stabilize the voltage. It will be, I think, 1.9 something, 94. Then it is a MOSFET. Then requirement of diode. and to cathode. Drain to source, we have to calculate connect 10 at a part is, and drain source will be negative. Take a voltage measurement, measure the voltage of output. And make a current measurement for measure the inductor current of this one. We use pulse generator. Amplitude 1, frequency is there, time period of 150 kilohertz, usually 42%. Take a power give for initialize this system. All of is there. Yeah, you can say this is a 29.9 something. This will be because of the some losses. That diode is on resistance is 0.1 ohm there, and diode resistance is also 0.001 ohm, and voltage drop is 0.8 volt. That's why there is some voltage drop of 1 volt. We just go to see the yeah. You can measure the inductor ripple. It will be 13.5 to 16.5, approximate 3 ampere. Change the color of this one. Visualize this one. Okay. And the same thing, if you want to do the same thing in closed loop system, then what type? You should have a controller known as a PI controller. Simply add PID controller. Simplify this, use only PI controller. Just check this one. Then you need the voltage, go take a go to the simple as V naught. Then you have to give a reference signal by a constant. So if you want to 30 volt, you take a 30 volt. Then compare this one by with error signal. Yeah, this will give the error signal of this one to minimize the error 0. Give the duty cycle. Then you have to take a duty cycle from here. Time period of this one, same thing. In place of this one, take this one. Both have same. Can say 50 kilohertz. Same thing you can give to your MOSFET. Just draw this one. Ah, this will be a approximate constant 30 volt. If you want to change as a 20 volt, this is 20 volt. It will be a I think controlled. Want to give 40 volt. Yeah, this will be 40 volt. By using a different value of the proportional and integral gain, you can adjust overshoot voltage of output voltage. So the integral is too high. If you want to decrease this one, you can see if you and decrease the integral value, then you should take some error up there, and if you decrease the kp value, then there is taking some time, a delay time to track this one. It will take approximate 0.4 second. Okay, in this condition, if you increase this same value 1 and 10, then you can see this will be very fast compared to this one. Yeah, 1 millisecond settling time is 1 millisecond. It will be very fast settle, depending on the kp and ki values. Okay, same thing if you want to apply a MPPT on this buck converter, then you have first take a PV array. Take a 250 watt, 2 parallel and 2 series. There are 2 parallel panel and 2 series. There is a single panel is known as 2 from 250 watt. The n number of cells is there, PV cells, to make a module, PV module. Open circuit voltage is 37.5 volt. Short circuit current is 8.76 ampere. The voltage at maximum power point is 30 volt, and the current at maximum power point is 8.24. And you can visualize same thing at a different uh, 400 maximum power you can see here at 1 kilowatt per meter square. It will is irradiance, it will be 998 watts, and at 800 it will be 805 watt. Here 60 at zero point 0.6 kilowatt is the 6 watt, same thing like 1 kilowatt. In place of voltage source you can apply this one. Irradiance temperature you can vary according to you. Temperature, if normal temperature 25 degree, standard temperature this will be 1000 watt per meter square irradiance. Yeah, if you want to control from this one, it may be possible to control this because but this will not working on a maximum power point, because it work according to the given reference signal, but you gives the reference signal to this one is the voltage of 40 volt output voltage maintaining, then you can't be supply the at a maximum power point. Any voltage you are 30 volt to reference it will give the 30 volt constant power. There's some error because of the making a high voltage. Again there is a error. There is a discontinuity at the input side because of the switch is there. If switch is there, then if switch is off, then no current is flowing through it. Then just take a large capacitor here. Okay, you can't be connect ideal capacitor directly through it to across the voltage source, because both are the voltage source and it will be in balance. That's why you have to take some resistance, very low value, then apply. Yeah, that will be maintain at 20 volt. So it take time because of the I have reduced the value of Kp and Ki. There is an oscillation because of the integral gain is very high. That's why it gives some oscillation is there. If you increase the integral gain, then they give the oscillation. Now, if you give 30 volt, there is a 30 volt, but it is operated, but it's not operated at a maximum power point. If you calculate this one, this will be a 30 volt, and the resistance will be 1.94. It means it will operate at approximately 500 watt. But your maximum power of this one at 1000 irradiation is 100 kilowatt. Sorry, 1000 watt, approximately 998 watt. But it gives only 500 watt because of you have to because you fix the output voltage. If you fix the output voltage, resistance also fix, then you fix the power. If you fix the power, it will can't be operated at maximum power. Then you can choose anyone. If you want to maximum power, then you can't be fix the voltage at the output side at resistive load, because this is the resistive load. The resistive load is there, then you can't be fixed. If there is a battery charging, then you can give fix the current. Sorry, you can give the reference as a current, because the voltage is fixed there, and any current it will take. But here it will current take according to the resistance of output. Then if you want maximum power, then replace this thing. Take a input of this one, measurement. This will give the M is measurement of PV array. Take a bus selector to select the voltage and current of this one. Then it gives the current signal 1, a signal 2 is there. Take signal 1 as a voltage, signal 2 as a current. Sorry. Then how write a code for this one, for maximum power, for a buck converter, in which you can write in MATLAB function. MATLAB function, write a code for maximum power here. This function is denoted as the y is the output and u is the input. You need the output as the duty cycle. Take a sorry, output here. You need a duty cycle is there. Input, you have to give input as V and voltage and current. Then give the two options, give the voltage and current. Voltage here, EPV, give the current is here. Regarding to voltage and current, write an algorithm for maximum power. That it gives the duty cycle. That duty cycle you can connect here to your okay. Then how to write code for this? This is the maximum power. You can see this is the VM. Same thing, R not equal to RS. We have to match this one. We have to match the R naught and RS. Then at t is equal to 0, what happened? R naught is equal to 0. Or RS will be infinite. This curve is the input side of the converter. Because of this is the solar curve. Then we should have to RS, source resistor. It will be infinite, it means open circuit. This will be a VOC at d is equal to 0. Then what at d is equal to 1, RS is equal to R naught. Suppose this is the R naught curve at d is equal to 1. Fine. We have to track this maximum power. And apply simply perturbation observation P and O method to track the voltage or the maximum power. We have two things. This is the maximum power. You can go to there from here, or you can take a 2 point, and you can go to, you can give the max initial duty cycle. That duty cycle is represent two things. Are we here? Are we here? There is also two chance to go there. Suppose this is first thing. Second thing, if suppose if delta P power, it means power will be negative here because of the power is decreasing and voltage also decreasing. The power is not equal to 0 or the power is less than, delta P is less than 0. Delta P less than 0, it means if a power uh, del power, it changes into power will be negative. That means it will go here or here. There is a two chance. There are two conditions when the uh, delta P will be negative. Change in power is negative. Then we have to write another also. Delta V is less than 0. If a delta V, if a voltage also negative, change in voltage also negative, then in what condition is there? Only this condition. It identify this thing. If power is downside and voltage also decreasing, then this condition is fulfilled. Then what happen? It means you have here something, and that load line is this one, d is equal to 1. Then you have to decrease the d because of P is here, maximum power is here. Then you have to decrease this one. Then d is equal to d old minus of delta d. D old, it means which one we will give the initialized delta. Suppose you can give 0.5. Then delta d for something we have to choose 0.001. Anything you can choose. Then this will be a negative. It means you have to decrease more duty cycle. Then it will be commence the here like that. Else, if this is not there, it means if delta p is not there, greater than 0, then this condition is there. Because of here delta p is negative and delta v is positive, else means is positive. If delta v not equal to 0, not less than 0, then it will be greater than 0. It means positive, voltage increases. Then D is equal to D old plus sub delta D. Then you, if curve is going downside, then you have to go to upward. Then simply add duty cycle to upward, goes to upward. Same thing, this will return for two condition, remaining two is there. Then you can write same thing for these two also. Same thing, if delta V, same thing, delta power is greater than 0, or you can write as a S self delta P greater than 0, or you can write else only. Then you can, it will also take as delta P is greater than 0. If it is not delta P is not equal to, not less than 0, that means delta P is greater than 0. Then you can write this two things. It means delta P is increasing. Again, we have to take if delta P is less than 0, then which one condition? This condition is there. Then in this condition you have to add duty cycle. Then D is equal to D old plus delta D. Same thing, if delta V is also increasing, is this one, then we have to decrease the duty cycle. This thing you can say, write our algorithm, then you can find the maximum power from a PV system. Okay, let's do it on simulation. Sorry. D old as the D initial value. To off this one, if value, take simple int. That will be completed. Then first calculate the power for find of delta P. Power is equal to B into I, which one coming from here, from solar. Then calculate the simple use delta del V, check or del T V, you can say del V is there. This is B minus of B old. Next one is del P power. Power is when calculated as that instant, then P old. Same thing if you and then applied the code here. If del P is less than 0, so capital P is, yeah. Same thing if again del P is two condition, when maximum before the maximum power point and after the maximum power point. Then again find the del V, which is also less than 0, no record of semicolon. Then what is the duty cycle? Duty cycle is equal to D old minus del D. Else else it means this one, if delta V less than 0. If else it means if delta V is greater than 0, then duty cycle is equal to D old plus of del D. Else means this one else, if else second condition delta P is greater than 0 and again delta V is less than 0, then D is equal to D old minus of del D. Oh, this is positive, opposite of this one. Else D old minus of del D. Take a int function to give this if, again int function for this elf. Okay. Take as the d old, again update this one, d old is equal to d, and p old is equal to p. For next iteration, b old is equal to v. Take output as a power also, and you can measure the power. Okay, let's check what happened. There's error something. Yeah. Power is 996, approximately 1000 watt. Same thing you can see here. It will be 998 watt. Suppose I will give, here is 800, then it will track 800 watt. Okay, because at 800 the maximum power is 805 watt. Here also 804.7 approximate same. It means it will track the maximum power by this code. Same thing, take at the 600. At 600 is 607. Yeah, same power. You can see here the voltage also change. When I decrease the irradiation, then voltage also decreasing, and current is there. Current also decrease to, if we increase the irradiation, then current voltage both are decreasing. You can check here. 9.8 ampere current, 61.8 is the maximum power. maximum power is at 60.2, wow, at 600 61.2 volt at a maximum power. You can say this is the curve of maximum power point versus voltage, and the current is there at a 600 watt. The maximum power is 9.8 ampere, 87 ampere approximately. This one you can say same power, same current is here. It's the current ripple. Ah, fine. 6 to 90, there's a ripple current is reduced because of the high current is flowing here. You have calculated the ripple current at 15 ampere, but is current is 17 ampere is there. That's why if current is increasing, the ripple will also decrease because of delta IL. Inductor is fixed, delta IL will decrease. If I not increase, then delta IL will increase. Oh, sorry, decreasing. At starting, there is 22 ampere approximately. Current is flowing at output current. This is the inductor current. Average of this one is the output current. Capacitor current you can see by using a current measurement. Okay, you can see the blue one is blue one is output current. inductor current, so the capacitor current. And so you can say that the capacitor current is inductor current minus of output current. Blue one is output current. If you subtract this one, then you can see the capacitor current is from 0 to positive. And we know about the capacitor current. The average of capacitor current in a cycle is 0. Same thing inductor voltage in a switching period, that in average of inductor voltage will be 0. These two is known as the flux balance and charge balance. If both are not satisfied in your circuit, then you can't be operate the circuit. DC-DC converter, because of this is the DC-DC converter, and voltage, input voltage, output voltage, both are DC. And inductor and capacitor is not operated in DC. It gives the open circuit, will be open circuit or short circuited. If you want to operate the inductor and capacitor in a DC converter and DC circuit, then you should follow the flux balance and charge balance. Flux balance for a inductor and charge balance for a capacitor. Flux balance, it means how much it will be store the flux in on duration. Same flux will be reduced or discharge at a negative current where on switch is off condition. Same thing is the charge balance in the capacitor also. If you want to see a inductor voltage, then simply apply a voltage measurement. It's inductor current. Sorry. Yeah, you can say 0 is here, positive cycle is approximately 28, positive voltage is approximately 28 or something. And Vs minus of V naught, Vs voltage 62 volt, V naught voltage is approximately 33.5. If you subtract this one, then you can find. And the negative voltage is minus of 30, voltage 33.56. And you can see the positive voltage is less compared to the negative voltage, but duty cycle will be more in positive direction. Because of the in positive duration, the switch is on, then positive voltage appears on the inductor for a very for a high time, more than 0.5 you can say, because of these lines is a 0.5 duty cycle, it is greater than 0.5 duty cycle. That's why positive voltage is more than the negative voltage. Negative voltage is more, but duty cycle will be less. That's why the average of both is 0, positive and negative. You can see when switch is on, the voltage appears positive voltage, current will be charged at the positive slope. The switch is off, current will be discharged in negative slope. The open circuit first flow that it will extract the maximum power. To increase this one. But want to draw voltage versus current, voltage to power, simply use these two workspace for power P, voltage V, run this one. The same value will transfer to our workspace. In workspace, you can plot your curve voltage versus power, power versus voltage. Okay, I'll just stop this one. Goes to workspace. This is the out P and V. Taken taken array form, not time space. This is V, this is P. Plus P. Oh, sorry, out of P. Dot P. Oops. Oh, 1014596. Another is 1274. That's why I do not got it. Okay, first save this one. E to power minus 6. Check the both the sample time is same. And get the same number of sample. To give some, I think. Oh, it's plotted, but it's plot to here. That's why it's not showing. So it's, yeah, you can see this is the maximum power tracking. We start from here, then go to maximum power, and some condition we return to here and plot the maximum power. If you change in middle of this one, suppose, but we start at maximum power, then I want to change the irradiation. Take how it will track. Let's take one two. also track this one. When I change the radiation, then it will be tracked like that, a maximum power suddenly. If I track another, if you give the reference, the radiation, it will track here like that. You can see. Okay, let's start from 1000. Wait for some time. Track. Yeah, you can see the tracking of maximum power. It will first start from 1000. It will be okay. Then 800 watt, the 400. This is 400. This is the 600. For a 600 radiation, 607 watt. This will be 400 uh, 4 watt. This will be 804 watt. And this is the maximum 996186. Okay, everyone. And if you have any doubts related to this, you can ask. I want to wind up here. Okay. Thank you. Thank you to all. And best of luck for your exam.
Thank you, sir. Sir, I got one doubt, sir.
Yeah, okay. No.
Sir, what kind of converter do we use in real practical applications in the solar PV modules, sir?
It depends. If you want to charge a battery in battery condition, you use a buck converter. And in for go the connect to the PV grid system, there use of a boost converter. Buck boost converter is very rarely used because of the negative voltage there. In place of
Right, sir. So,
buck boost converter, it will use the Sepik converter, Chuk converter is there, a flyback converter. The different thing. These are used, but maximum times when practically buck converter and boost converter is used for MPPT.
right. Sir, what about in EV applications? What kind of converters they use? Sir? They are also same buck and boost only, sir.
For EV application,
Yes, sir.
yeah, simple buck converter.
Simple buck converter they use there, sir.
Yeah.
Right. So, okay. Thank you, sir.
Okay, welcome. Okay, then thank you to all. I stopped here. Best of luck for our exam.
Thank you, sir.
Okay.
Thank you, sir.